Alright, welcome back. In this video, we're going to go over bond line structures as well as some practice problems. So the agenda for this video is first we're going to go over what a bond line structure is, why do we use it, how do we use it, and then we're going to go over some practice problems, well, a lot of practice problems. And notice we have got a challenge problem here. So what I'm going to do with the practice problems is we're going to go over all of them really slowly. But we're going to start out easy, go to medium intensity or difficulty, and then we're going to go hard. So we're going to make those challenge problems. The challenge problems are meant to simulate a real exam question. Because let's be honest, I know exactly how organic chemistry works. And now, because I was a student, as an organic chemistry student at some time. You would go on YouTube, you would look up an organic chemistry video, you would understand how to do it, but then when you get to the exam, it's a lot harder than you practiced. Because the professor tries to trick you. I'm here to combat that issue. We're going to do the challenges here and go over something what your professor might give you, and then you won't stress about it on the actual exam. Because you'll know exactly how to do it and all the other students will not know. So let's start. So in organic chemistry, we deal with a lot of big molecules. Here is amoxicillin. This is called the Lewis structure of amoxicillin. The Lewis structure is where you draw out every single atom and all the electrons. This is also known as what I like to call a complete waste of time. Imagine if you were in a test and you had to draw the Lewis structure of amoxicillin. And it's a 50-minute test. Well, you would spend a lot of it just drawing this out and making sure you got it right. Double checking, triple checking, quadruple checking. 10 minutes could just go in by drawing this. That's where we have bond line structures. Bond line structures are essentially a shorthand way of drawing what we just did. What I just showed you. This is still amoxicillin, same exact molecule, except it's represented differently. It's represented with a lot of lines. What the bond line structure does, it essentially eliminates all the carbons and changes them with lines. In addition, we also wipe out all the hydrogens that are attached to carbons. So bond line structures, let's go over actually how to write it out and what they are. Bond line structures have some rules to them. Bond line structures are drawn in a zigzag formation, with every corner or bend or even at the end of the molecule is representing one carbon atom. So let's go over here. This looks like a regular old zigzag, but there's actually a bond line structure. This is indicating that we got a carbon here, 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 and a carbon here. So anywhere there's a bend. So we got a bend here, a bend here, a bend here, and a bend here. Those are carbon molecules, atoms. And at the very end of the line are carbon molecules as well. So you got 6 carbon molecules here. In this example, let's see. So we got the end of the line here, that's a carbon, end of the line, carbon, end of the line, carbon, end of the line, carbon, a carbon at the intersection, because that's a bend as well, and a carbon here at the intersection, a bend as well. We've got 6 carbon molecules, atoms, sorry. So let's take a look back here at amoxicillin. There's a lot going on here. But let's break it down slowly. How many carbon atoms do we have here? Let's start from here. So we got a bend here, that's a carbon. Got one here, 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 one here, one here, 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 here. And I think that's all of them. Yes. Yes, sweet. Notice we do not have one here in this section area here. The reason is because if the end of the line has another atom located there, there's no carbon. So you have a nitrogen at the end of the line. The end of the line here is representing a nitrogen. The end of the line here is representing a nitrogen, and here's a nitrogen. Sorry about that. Okay. More rules. Carbon, by default, must have 4 bonds. This is like 99% of the time. If no atoms are bonded to the carbon, automatically assume there are hydrogens bonded to carbon to fulfill the 4-bond rule. We do not write any hydrogens bonded to carbons in bond line. For any other atom, write the hydrogens. So what does this mean? So first, this is the Lewis structure. However, this Lewis structure is wrong. Why is it wrong? The reason it's wrong is because there's no hydrogens present in this. And remember, in the Lewis structure, we draw everything. So what do you mean by hydrogens? Well, carbon, by law, by default, must have 4 things attached to it. We have 1 bond here, so that's 1. Where are the other 3? Well, there are hydrogens. So whenever carbon is alone and does not have 4 bonds, make bonds, essentially. You're going to put hydrogens where there are missing bonds. So now we satisfied the 4-bond rule. We got 1, we got 2, we got 3, we got 4. So carbon is now happy. This carbon's happy. So that's all you have to do is whenever you see carbon not having 4 bonds, add the remaining hydrogens bonded to him. So this center carbon, is this fine? Is this normal? Is this correct? It is. Because we got 1 bond here, another bond here, and we have a double bond here. So this counts as 2. 1, 2, 3, 4. So this carbon is happy. We don't do anything. This carbon is not happy. It only has 1 bond. So we've got to draw in the rest of the hydrogens. So if we only have 1, and we need 4 in total because carbon must have 4 bonds, we just add 3 hydrogens. That was the Lewis structure, but what about the bond line structure? How do you draw that? So the tip, I would say how I like to do it is by numbering it. Whenever you draw a bond line structure, first count the number of carbons you're dealing with. So here we're dealing with 3 carbons, 1, 2, and 3. So our bond line structure must have 3 carbons. But be careful. Do not just draw 3 lines. Because let's look at what happens when you do that. 1, 2, 3. That's 3 lines. Notice that this is not 3 carbon atoms. What we drew is 1 carbon, 2 carbons, 3 carbons, and 4 carbons. So you have to be careful when you actually draw bond line structures. This is how you do it. Instead of counting from 1, starting to count from 1, start to count from 2. What do you mean by this? Let's do it. So when you draw the first line, this is going to count as number 2. So let's do this. 2, 3. Like that. So what we did is we drew in a carbon here, here, and here. But now we have to include the oxygen. So all you have to do is draw the double bond and have the oxygen with the electrons. And that is the bond line structure. We do not include the hydrogens that are bonded to carbon. They're unimportant. They're a waste of time to draw, so we just don't draw them. I apologize if you can hear a helicopter in the background. I actually live right across from a hospital with a helipad, so they're frequently doing like emergency pickups or whatever. Let's look at this one. This one's wrong. Because notice that this carbon right over here only has one bond, so we need to satisfy that 4 bond rule. 1, 2, 3. Is this center carbon okay? Is that correct? It is not. Because this carbon has 1 bond, 2 bonds, 3 bonds. We are missing 1 bond to satisfy that 4 bond law. So we add a hydrogen. Ta-da! And then this carbon is lacking 3 bonds, so we add hydrogens, 3 hydrogens. How do we draw the bond line structure for this? Be careful. So, the bond line structure for this is 2, 3. So we got our carbons done. A nitrogen here. And this is not a carbon. This right here is not a carbon because we're directing it towards a nitrogen. We're facing it towards a nitrogen. That means there's no carbon. We're only dealing with the nitrogen here. Okay. Here's a question. Do we draw these hydrogens? Or do we just leave them out like where we left it off here? You do actually. But you draw it like this. Like that. You just count the number of hydrogens and draw it right next to the nitrogen. So this nitrogen is called a heteroatom. A heteroatom is any atom that's not a carbon or a hydrogen. For any heteroatom, you must draw the hydrogens attached to it. You cannot leave it. That's one of the laws, the rules. So let's look at double bonds here. Double bonds are interesting where you draw basically a second line right next to the line that has the double bond, the carbon that has the double bond. This is not this is not showing you that you have a carbon here, a carbon here, and a carbon here, and a carbon here. No, no, no. What this is showing is that you have this, like that, like that, like that. This is what this bond line is showing. Is you have a double bond between this carbon and this carbon. If it helps, you can actually label them too. You can actually number them. This is 1, this is carbon number 2, this is carbon number 3, this is carbon number 4. So we do the exact same thing. 1, 2, 3, 4. And there's a double bond between 2 and 3, and we do have 1, 2, and 3 of a double bond. Triple bonds are interesting. This actually messes people up. Triple bonds must be written linear. So, you have to be careful with triple bonds. Because triple bonds are written like this. You have first basically a carbon here and a carbon here. Now, where the triple bond happens, there's a gap. Notice this gap here. This is significant. I cannot speak English today. This is showing you that you do not have 2 carbons, you have 1 carbon. Because what you would think here is that you would have a carbon here, a carbon here, a carbon here, a carbon here, and a carbon here. That's not what it's showing you. That's not what the bond line's showing you. It's showing you have a carbon here, a carbon in this gap, a carbon in this gap. So, let's number it first. Let's do the numbering strategy here. So you got 1, you got 2, you got 3, and you got a 4. So, let's draw it. So we got a carbon here, like that. 1, 2, 3 for our triple bond, a carbon, and a carbon. And just for the number's sake, 1, 2, 3, 4. And we got our triple bond between a 2 and a 3, carbon number 2 and carbon number 3. So you got a triple bond, carbon 2 and carbon 3. There we go. So let's talk about what this is actually showing you. I want you to do me a favor. Show me how many carbons and hydrogens are in this atom. this molecule. So let's do that. Actually, do not show me the carbons. No. You can if you want to. But write out how many hydrogens there actually are on this molecule. Let's do that. Okay. I'm purposely doing this. You'll see why. So let's draw the bond line. Okay, that's what we have so far. Now draw only the hydrogens. I'm training your brain for a reason. I'm helping you recognize to see the hydrogens without actually drawing the carbons in. We actually technically drew the carbons in, but as lines. But I want you to actually write the carbon, the letter C, and then the hydrogens attached to it. I want you to visualize where the hydrogens are without drawing that C to indicate carbon. So here's a trick. Whenever you're at the end of a molecule like this, there's always 3 hydrogens present. So you got 1, you got 2, and you got 3. Can this carbon right here hold any hydrogens? Are there any hydrogens there? The answer is no, because we got a bond here, right? This is the point we're looking at. Bond here and a bond here, that's a double bond. So you have 4. That's too many. Carbon cannot hold. So you move on to the next one. Can this carbon hold any hydrogens? It can. We got 1, 2, and so you must have a 3 and a 4. So like that. So let me draw it in. Same with here. Same deal. Because you got 1, 2, 3, 4. There we go. And we're at the end of the line, so that means we got a 3. Sweet. So let's do some practice problems. This is starting easy, medium, and hard. The hard is not the challenge one, by the way. For each of the following molecules, indicate the number of carbons and hydrogens. Let's do the first one. You can pause the video if you like and try to solve it yourself. So here we got carbon here, carbon here, carbon here, carbon here, carbon here, and carbon here. Wherever there's an intersection, a band, or at the end of the line. So that is 1, 2, 3, 4, 6. 6 carbons. How many hydrogens? If I'm not mistaken, there should be 14. If I did my math correctly, let's see. 14, okay. 1. We're at the end of the line, so you must have 3. This one has 2. This one has 2. This one has 1. Because we have 1 bond here, another one here, another one here. This carbon's missing a bond, so it must be a hydrogen. This one has 3, because we're at the end of the line. This one has 3. So let's count, just to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Sweet. 14 hydrogens. Let's do B. This one's trying to fool you. First, let's do carbons. We got a carbon here, carbon here, carbon here, carbon here, carbon here, carbon here, a carbon here, 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 and here. This should be 12 carbons. Just a little heads up. Whenever you see this ring-looking structure with 6 carbons and double bonds, 3 double bonds in the ring, this is called a benzene ring. It's some very interesting properties, and we'll go over that when we get to chapter 14. Yeah. So how many hydrogens? If my math is correct, we should have 18. So we're at the end here, so we must have 3. 3 here, 3 here, 3 here, 3 here, and 3 for the last one. Okay. Do we have any hydrogens in the actual ring itself? This is the ring. We do not. Because you'll see, this is why benzene ring is super interesting. At every single point, carbon has 4 bonds. This carbon, for example, 1, 2, 3, and then double bond is 4. Here, 1, 2, 3, 4. Here, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Everywhere in the ring, carbon is basically satisfied. So the answer is 18 hydrogens. Now, this is a little bit of interesting. This is called a chair conformation, so there are different ways how to draw molecules. This is a very fancy way. But still basically like a bond line structure. What would you do here? Try it out. This is something you could see on an exam, by the way. There should be 7 carbons. 1 here, 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 and a tippy top there. Because remember, everywhere there's an end point or intersection. Or a bend. 1, 2, 3, 4, 5, 6, 7. Awesome. How many hydrogens? There should be 12. 1, 2, 3, 4, 5. Be careful here. This carbon has 1 bond, 2 bonds, and 3 bonds. So now the 4th one is the hydrogen. This one has 2. This one has 2. This one has 1. Because same reason as basically this one. And then the tippy top one has 2. 1, 2. 2. Because it has 1 here and 1 here. Now the 2 is 1 and 2. That's 4. Let's count them up. It should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Awesome. Alright, challenge problem. This is definitely something you would see on an exam. It looks complicated, it looks hard, but it really isn't if you take it slowly. This is Xeljanz. This is a medication you've probably seen it on a TV commercial. This was used to treat psoriasis and rheumatoid arthritis. So let's count how many carbons. How many carbons and how many hydrogens? Well, start from left to right. Remember, there is no carbon here because it's followed by a nitrogen immediately after. But there is a carbon in this space. Remember the gap for triple bonds? So there must be a carbon in this gap here. That's 1, that's 2, there's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes, that's all of them. And once again, there is no carbon here because it's followed immediately after a nitrogen. There's no line. This is pointing towards a nitrogen. This is pointing towards a nitrogen. You can also think of it as this is not the end of the line. Right? This is not the end of the line because there's something right after it. Unlike something like here. Right? There's nothing after it. There's nothing here. Right? So this is the end of the line. Here, not the end of the line, because you can still go on and hit something. How many hydrogens? It should be 20. So let's see. Does this have any hydrogens? It does not. 1, 2, 3, 4. This has 2, 2, 1, 3, because we're at the end of the line. 1, 2, 3, because we're at the end of the line. Always 3 carbons at the end of the line. That's fine. That's fine. This is not fine. 1, 2, there. And Okay, did I get all of them? Let's see. Should be 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yes! Okay. That's all of them. Remember, don't forget this one, right? I even drew it in for you. I was nice. Well, you kind of had to because it's bond line, right? This is a heteroatom, so you must draw the hydrogen. All heteroatoms, any atom that's not carbon or hydrogen must be drawn in. So how do you do this one? Well, remember, we have to first count how many carbons we have. You have 4. 1, 2, 3, 4. So then you draw the bond line structure, but remember, you have to draw it in a zigzag and starting with the number 2. Because let's show you again why if you start with 5, it's going to be wrong. Let's do this. 1, 2, 3, 4, 5. So we drew 1, 2, 3, 4, 5, 6 carbons. We have one. Yeah, this is not good. Not good at all. Sorry, did I say 5 carbons in the beginning? Sorry, do not remember. But it's 4 carbons here. I didn't make a mistake. Okay, well, okay, it's 4. It's just having 4 carbons. Let me just draw this. Okay, 4 carbons. So what happens if you drew 4 lines? 1, 2, 3, 4. I'm so sorry. Yes. So carbon, 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 carbon. So that's 5. That's too many. So you start with 2. The number 2. 2, 3, 4. Like that. And then we ignore all the hydrogens because they're not important. And we only draw the heteroatom, which is the oxygen. So oxygen. Now notice the hydrogen's bonded to the oxygen, so we must include it. But since it's bonded to the oxygen, we just do this. This signifies it's bonded to the oxygen by being next to each other. And then we have to include the electrons. Okay, there we go. Ta-da! Draw the bond line structure for this massive beast. Okay, we'll take it slowly. So all I did is just copy this, like I just copied it. So this is the exact same thing as this. Same thing. The first thing is you need to delete all the hydrogens except the heteroatoms. So all the hydrogens you see, delete them, erase them. And only include the ones from the heteroatom. So let's do that. So starting from here, so we got OH, because remember, this is bonded to each other, so we just draw it as together. Carbon, carbon, oxygen, carbon, carbon, triple bonded, because now we're here. Carbon, double bond, carbon, and carbon. There we go. Easy. All I just did is erase all the hydrogens and connected this OH, the oxygen and hydrogen, because that's what it is here. Okay. Now we just zigzag all the carbons. That's it. Just zigzag them. Don't do anything else. And make sure you draw the triple bond linear. So let's do that. So I'm just going to rewrite it this way. Honestly, the hardest part of this is just drawing a zigzag. It's geometry skills. Now, be careful. Actually, let me make this one neater. So we are at this position right here. So you're followed with the triple bond. We do not make it zigzag. We have to make it straight. So we do this. 1, 2, 3. Straight. In one direction. The following carbon must be also in that same direction. And then we can draw the carbon here. Sorry, running out of space here. But yes. There we go. Let me just make sure I got them. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Nice. Now we have to delete all the carbons. So, this is the last step. Delete all the carbons. So let's do that. So we got 1, 2, and this is oxygen. Like that. And then now we're at the triple bond. So we drew in, so that's actually, what we can do is actually, let's number it. This is carbon number 1, 2, 3, 4. So this is 1, 2, 3, 4. So we're at the triple bond now. So what do? Okay, we leave a gap to signify there's a carbon there. Oops, wrong color. Like that. And then we draw like that. So this gap is telling us that we have a carbon here. So this is 5. This is 6. Now what do? Do this. Like that, and like that. This is carbon 7, 8, and 9. 7, 8, 9, and include the double bond. Do not forget this. Ta-da! And that's it. That's how you draw it. So it's very useful to actually number your atoms, your carbons. It makes it really easy. But yeah, I hope you enjoyed my first official video of organic chemistry. If you found this useful, please like and subscribe. And if you guys really enjoy these videos, the original plan was to do the entire book, but I'm still going to do that. But depending how many practice problems you guys like, will depend on the support of the videos. So if you want me to do more practice problems, please support the videos by liking and subscribing and whatnot. So until next time, later.